Hello students, in this video we are going to discuss about the softening of hard water. First of all, let us define what is softening of hard water. The process of the removal of hardness from the water is called as softening of water. As we have already discussed, two types of hardness of water, that is temporary hardness and permanent hardness. The type of hardness is due to the presence of bicarbonate of calcium and magnesium salts dissolved in it is called as a temporary hardness, and this hardness is called as temporary because it can be very easily removed by simply boiling the hard water for some time. But the permanent hardness is due to the presence of chlorides and sulfates of calcium and magnesium dissolved in it. And these hardness cannot be removed easily by just boiling. So in this video we are going to discuss some of the methods which can be used for removing the hardness of water. So first let us discuss for the temporary hardness. Temporary hardness can be removed by boiling the water for some time. During the boiling, the soluble bicarbonate is converted into insoluble magnesium hydroxide as it is shown here. Here magnesium bicarbonate. So the temporary hardness we have already discussed. It is due to the presence of bicarbonates of magnesium and calcium ions. So when we heat the water, that when it is boiled, magnesium bicarbonate is converted into insoluble magnesium hydroxide, and here calcium bicarbonate is converted into calcium carbonate. So by this method, bicarbonate get converted into hydroxide and into carbonates. This carbonate get precipitated that can be removed by filtration. So by this way, that means by boiling the hard water, the bicarbonate get converted into carbonate and hydroxide. So in this way we can remove the hardness of the water. Even we can also remove the hardness, that is temporary hardness, by Clark's method. In this method, the calculated amount of lime is added to the hard water. What is lime? Calcium hydroxide is called as lime. A particular amount of lime is added to the hard water. So this is actually present in the hard water. As we have already discussed, temporary hardness is due to the presence of bicarbonate of calcium and magnesium. So these are actually present in the hard water. So when we are adding lime, that is CaOH whole twice, to this hard water, then the bicarbonate get converted into carbonate. As you can see here, bicarbonate is converted into carbonate, and here also this magnesium bicarbonate is converted into magnesium hydroxide. So what is happening here? Bicarbonate is converted into carbonate, and for the case of magnesium bicarbonate, it is converted into magnesium hydroxide. So during this, these get precipitated because precipitates are formed, and it precipitate out as a calcium carbonate and magnesium hydroxide. The symbol for precipitation is the downward arrow. As you can see here, downward arrow. It is representing that precipitates are formed. So here the magnesium bicarbonate and the magnesium carbonate is converted into the precipitates, and this precipitate can be filtered out, and the water which after filtering is now it is the temporary hardness get removed. That means now the water is become soft. But in order to remove the temporary hard water, that is quite easier, but removal of hardness, that is permanent hardness, does not be done by just boiling. So here some of the methods should be followed to remove the permanent hardness. First method is treatment with washing soda. What is the formula for washing soda? It's chemically called as sodium carbonate. So its formula is Na2CO3. Washing soda, chemical name is sodium carbonate and its formula is Na2CO3. So when we add washing soda to the hard water, and this hardness is actually due to the presence of chlorides and sulfates of calcium and magnesium ion. So instead of writing the calcium chloride or magnesium chloride, it is just written here, that is MCl2, where M is showing the magnesium or it can be calcium. So together we are writing here in a general form, that is MCl2 plus Na2CO3 is giving rise to MCO3 plus twice NaCl. Now you can rewrite this equation with a particular example like magnesium chloride, MgCl2 plus Na2CO3 is giving rise to, that is MgCO3, magnesium carbonate is formed and twice NaCl. So here the general equation is given. So you can try this equation for calcium also. So how will be the reaction? Calcium chloride plus sodium carbonate giving rise to calcium carbonate plus twice NaCl. So in this equation also we can see that the hardness is actually due to the presence of magnesium chloride and calcium chloride. Now it is turned into precipitate. Now it gets precipitated out in the form of carbonates. Similarly, magnesium sulfate and calcium sulfate get converted into magnesium carbonate or calcium carbonate that get precipitate out. So when we filter it, this precipitate can be removed. Now the water is said to be free from the hardness, because these are responsible for the hardness. That is the chloride and sulfate of magnesium and calcium are responsible for the hardness. That is actually converted into carbonates, and that is actually forming the precipitate, so which can be filtered out very easily. So now what is remaining in the water here? Now in the water, sodium chloride and sodium sulfate is remaining. That is not at all responsible for the hardness. So we can remove the hardness by the treatment with the washing soda, that is sodium carbonate. Next method is the Calgon's method. Sodium hexametaphosphate, that is called as, commonly called as Calgon. Formula, what is the formula for Calgon? Na6P6O18. What is named? It was named as sodium hexametaphosphate. This is called as commonly Calgon, or commercially we can call it as a Calgon. So when the Calgon is added to the hard water, then the following reactions takes place. Like here the Calgon is added to the hard water. So what is happening here? There's a formation of complex that is seen in this equation, that is the metal ion here M2 plus, that is representing for the magnesium ion and calcium ion which is present in the hard water. When it combined with this Calgon, so there is a formation of complex anion, and because of this formation of complex anion, now the hardness will not be there, because the complex anion keeps the magnesium and calcium ions in the solution. Now you can see that M, what is M here? The calcium or magnesium ion. Now what we have in the water, now it is in the, that magnesium ion or calcium ion are in the complexes. So it will not at all affect the hardness of the water. So by this method we can remove the hardness, that is a permanent hardness can be removed by the addition of Calgon to the hard water. Next is the ion exchange method. This method is called as a zeolite method or permitted method, and it is one of the most important for the exam, because usually the question will be asked, describe the zeolite method or the permitted method, or in short answer type of question, the question will be asked, what is zeolite, what is the use of zeolite. So this method is called a zeolite or permitted process. Here, what is a zeolite? Hydrated sodium aluminum silicate is called as zeolite or permitted. So it's very important question. What is zeolite? Hydrated sodium aluminum silicate is called as zeolite, which is commonly called as zeolite. So for our simplicity, instead of writing the complete formula, that is NaAlSiO4, here AlSiO4 can be written as Z, so NaZ. NaZ, for our simplicity, instead of writing complete AlSiO4, instead of this what we are writing, Z we are writing. So NaZ plus M2 plus. What is M2 plus? That is M, here it is magnesium and calcium ion, which is present in the water. That is actually due to it causing the hardness of the water. So our aim is to remove this ion. So when we add the zeolite, that is representing here NaZ, so what it forms NaZ2 plus twice Na plus. So that means whatever the product which is formed here, it is not causing the hardness. This is actually causing the hardness, that is a magnesium ion and calcium ion with the chloride and sulfate is causing the hardness. With the reaction with permitted or zeolite, now it converted into metal zeolite, that is you can form the combination with the M and Z form. So this is formed actually which is not at all responsible for the hardness. So by this method, we can remove the hardness of the water, and this is called as ion exchange method. Why? Because here there is an exchange of ions that you can see here. In the place of Na, now M is taking the position. So what is actually here? The exchange of ions takes place, therefore it is called as ion exchange method, and it is one of the most important question for the exam also. The other method is the synthetic resin method. Nowadays, the hard water is softened by using the synthetic cation exchangers, and this method is more efficient than the zeolite process. Here, the cation exchange resins contain a large organic molecule with the SO3H group. So here, a synthetic, why it is called a synthetic resin method? Because in this an organic compound large chain of molecule and which have any functional group like SO3H group and are the water insoluble. So the ion exchange resin is changed to RNA by the treating it with the NaCl. So what is actually here taking place? Here the RNA, what is R here? The long chain of carbon chain and with the Na here. Now what happens when the magnesium ion or the calcium ion, when it is get treated, so what it form R2M. That means now the metal ion is with the combination with the resin. Here R is representing the long or the large organic molecule that is representing this. So here what happened, the metal ion get exchanged. So this is called as synthetic resin method, and is also an ion exchange method, because here also the exchange of ions takes place. That is clear from here. Here RNA. Now here in the place of Na, M is taking the position. So here there is an exchange of ion, and it is a organic, or we can call it as a synthetic resin method. So here we have discussed some of the methods in order to soften the hard water, that is the process of removing the hardness from the water. We have discussed for the temporary and for the permanent hardness. So all of you noted down this equation from the textbook, because these all images are taken from the textbook. So this is all about this video. Have a nice day.